Good morning, everybody. We're just waiting for some more participants to join. We have got over 200 this morning, so just going to give it a few more seconds and I will be back with you. So good morning, everybody. We will make a start. We're just after the hour. Hope everyone's doing well. Friday morning, always nice to get to that point. Welcome to the second in a series of webinars run by the Subsidence Forum. This one today will look at complex subsidence repairs and ground injection techniques. I'm Lauren Fairley, I'm the secretary of the forum, and I'm just going to cover off some housekeeping bits for you this morning. Chloe and myself will be doing all the background work and ensuring that hopefully the slides and the videos work smoothly. But please just remember, obviously, all internets are different, all internet speeds are different. So if there is a lull or if it does go slightly out of sync, please just let me know if you are having any major technical issues on the chat facility, but bear with us on those points. Also, if I could ask you to shut down any other apps you might have running, obviously that will help with your internet speeds as well. So just some bits to help you through how we're going to run today. There will be a questions and answer session after each section, so please feel free to use the chat facility at the bottom of your screens. I'm sure we've all used Zoom throughout this pandemic, but just to run over, you can use the chat facility in the toolbox. You have the drop down that says all panelists or all panelists and attendees. So just be mindful of that if you do want to direct any questions to particular people. You can also use the questions and answers section at the bottom. We will be monitoring both throughout, and Sarah, the Vice Chair, will be presenting those questions to the panel. There will be some polls as well as part of the presentations, so I encourage you to participate in them, and they are very straightforward. Again, probably used them before, but we will prompt you when they come up and you will see them. Finally, the seminar today is being recorded, so it will only be used for Subsidence Forum activities, and it will be on the Subsidence Forum website. So they're the housekeeping bits. As I say, if anybody has any difficulties or anything throughout, please just come back to us or put it onto the chat. I'll pass you over to Ron Mace now, who is the chair of the forum. Enjoy, everybody.
Good morning and welcome to the second instalment of the Subs Forum training event. My name is Ron Mace and I'm the current chair of the Subs Forum. I'm joined today by Patrick Isaacs, who's the head of the Training and Education Group, and Sarah Dodd, the vice chair. Also with us is Spencer of Optera and Alex of GeoBear. Patrick will discuss shortly the format of today's event and provide a little bit of feedback on last week's webinar. Before I hand over to Patrick, and as per last week, I thought I would just again remind all current members and those that are joining us for the first time, just some of the objectives that the forum is trying to push forward. These being improve public awareness of substance issues, promote the substance industry, improve lines of communication between all parties involved in subsidence, improve quality standards throughout the industry, and finally, establish a centre of shared knowledge and an exchange of non-competitive information. Last week's and this week's webinar event certainly ticks the last objective. If after today's webinar you feel that either you or your company can assist us in achieving our objectives, then could you please contact us. Thank you, and I now hand you over to Patrick.
Thanks, Ron. Good morning, everybody. Hope you're well. That's another great turnout today. We've had over 200 people register for the event, so thanks for your continued support. For those of you who did join us last week, you'd have heard some of this before. But we've got quite a few new people on today, so I'd just like to quickly explain what we're trying to do. As Ron mentioned, my name is Patrick Isaacs, and I head up the Training and Education Special Interest Group within the forum. And my main task is to arrange the annual training day. And if you've been to one before, you know it's a good day out, away from the usual grind, and a chance to learn about some new stuff in the subsidence world. Over the last couple of years, these days have been arranged as demonstration days, where our members demonstrate their skills and techniques in a live environment, replicating what they do on actual subsidence cases. So we've seen piles driven into the ground, we've seen some trees inspected and identified, drains surveyed and repaired, other interesting stuff like that. These days have proved a great success. Last year was completely sold out, and we were keen to do something similar this year as much as we could. And we'd like to think that that's what we've achieved with these webinars and the video demonstrators. So if you weren't on last week and you've seen some of the posts that have been going around or the advertising, you'll know that this year's event is going to be split into 3 separate webinars, and this is the second of 3. Last week we had Sarah Dodd, Vice Chairman of the Forum, and she hosted the mock-up of a tree root case. It was extremely well received by all attendees. We had 270 registered for that event, inundated with question and answers, and the feedback we've received afterwards has been overwhelmingly positive. So it's a great start to the year. If you did miss it, don't worry. As Lauren said earlier, it was recorded and is now available to view again and again and again on the Subsidence Forum website. So you've got no reason not to have a quick look. So that's what we did last week. This week, we've got 2 demonstrators. I'll shortly be handing over to Spencer Casely of Optera. They're a specialist structural repair contractor, and they'll be showing us what they do and how they do it, with a few interesting examples of root barrier installation, retaining wall reinstatement, and a couple of other really interesting case studies. The video will last 15 to 20 minutes, which should give us 5 to 10 minutes for questions at the end. And as Lauren mentioned earlier, please use the chat function to submit your questions to the panelists as we go along, and we'll do our best to answer them. Sarah Dodd, the Vice Chair, Sarah mentioned previously, hosted the session last week. She'll be chairing the question and answer session, collating the questions from the chat box and putting them to the panelists, and hopefully keeping a close eye on time. So around 9:30, 9:35, we'll draw the first demonstration to a close, and then Sarah will hand over to Alex Finch of GeoBear, our second demonstrator. Some of you may know GeoBear from last year. They gave a fantastic demonstration. They cast a nice concrete slab onto the ground and then promptly lifted it out of the ground using their injection techniques. Alex will be explaining how these techniques are evolving and can now be used on clay soils to tackle clay shrinkage cases. Again, there'll be the opportunity to put some questions to Alex after the video, and I think Spencer's still going to be around if there are any further queries for him. We aim to be finished by 10 o'clock. So that's today. The final session will be next Friday, starting again at 9, where we have another 2 demonstrators, starting with Shire Structures, and they'll be showing us how they go about undertaking site investigations on subsidence cases, showing how the soils are recovered, logged and described, and then find their way onto the usual reports that we all see. The final demonstrator for the event this year will be Helifix, and they'll be showing us some typical masonry reinforcement repairs, for use on damaged brickwork panels. We aim to sort of bring that to a close a few minutes early to allow Ron to say a few words to bring this year's event to an end. So that's how we see things mapping out for the next couple of weeks. I hope you enjoy the videos and learn something new. And I'll now just pass over to Spencer Casely from Optera to introduce our first demonstration. Spencer.
Thanks, Patrick. My name's Spencer Casely. I'm one of the directors at Optera. The video today, as Patrick says, is primarily around the installation of a tree root barrier, but there are also some other case studies of eye-catching jobs that we finished in the last 18 months. I hope you enjoy. Since its inception in 2013, Optera, based in the West Midlands, provide a UK service to the insurance domestic marketplace. With over 40 vans and 70 personnel out on the road, we provide innovative repair solutions to subsidence, heave and landslip cases throughout the UK. As a multidisciplinary company, Optera differentiate themselves from the marketplace by offering design and build solutions, negating the need for insurers and their loss adjusting clients to incorporate an external engineer prior to going out to tender. This time and cost saving enables Optera to offer innovative and cost effective solutions within the insurance domestic marketplace. Since the inception of Subsidence as part of the policy cover, clay shrinkage subsidence has been an ongoing issue to the insurance domestic repair sector. Historically, rectification of subsidence claims were via underpinning or some mechanical intervention within the property. However, during the 80s, the formulaic approach of investigate, mitigate, monitor and repair has been a stalwart within the insurance repair sector's response to these issues. This is fine as long as the tree is within the ownership of the insured or the third party is willing to cooperate, but when the trees are protected or the third party is unwilling to facilitate mitigation, problems arise. This can often lead to expensive underpinning solutions as an alternative, and Optera have identified root barriers as a viable alternative to the intervention with underpinning. Root barriers historically have a poor reputation, comprising builders' plastic or concrete barriers, both of which were vulnerable to ground movement, puncture from roots or cracking due to ground movement. Optera have brought to market the copper impregnated geotextile fabric barrier, which differs from those previously insofar as it remains flexible and is able to move with ground movement, but resistant enough to prevent puncture, whilst incorporating a perforated copper centre which provides low-grade copper iron to the ground, providing a chemical deterrent to tree roots ongoing. Copper impregnated biobarrier is installed on jobs where there is sufficient room on the site to allow mechanical plant to access the works area, and typically this involves bringing in a 5-ton excavator into domestic property. A working area of approximately 3 metres in width is required in order to carry out the works, and using the excavator a trench is formed 300 millimetres wide down to a depth somewhere between 3 and 4 metres, and the material is then removed to the dumper and taken to an area on the property where it can be collected by grab lorry. Where we're working in particularly tight sites, we're able to store spoil in skips, although this obviously affects the price of the works. The barrier itself is cut prior to site having been designed and brought in sheets approximately 5 metres long, which are subsequently jointed and taped and lowered into the trench. Once the excavations have been completed, the works are typically undertaken in 5-metre lengths, as we are working within the tight confines of a site and are conscious of destabilising the property. When working particularly closely to the side elevation of the property, we may reduce the length of the excavation to 2 to 3 metres, mimicking the working practices of underpinning, thus reducing the possibility of destabilising the property. This may also affect the material that we use to backfill the excavation upon completion. Once the excavations have been formed, the barrier is dropped into the trench to the bottom and a small section overlapped to surface level. The leading edge of the excavation is bunded using sheet piles in order that the backfill 20mm single-size stone that we use to fill the trench with does not migrate into the leading edge of the excavation. The length and depth of the root barrier is influenced by a number of site-wide factors. These include the size and position of the trees relative to the property, any designations or protections that those trees may have, including TPOs, and equally the depth of the roots which were established during site investigation prior to us undertaking works on site. The barrier is designed typically to go at least 1 metre beyond the last detected root within the site investigation, and the distance from the tree to the barrier is typically 5 metres where possible, and certainly when TPOs are involved, 5 metres as a minimum. The backfill material is either 20mm stone or no fines concrete when we are particularly close to a property, which is brought in up to about 200mm below ground level, and then the surfaces are reinstated to match existing. The type of backfill is influenced by the number of site conditions, including the proximity of the barrier to the property, and the site is then left tidy upon completion. The process is a much simpler and more cost-effective solution to traditional underpinning techniques.
Landslip has developed a backscarp which is within about 3 metres of the rear of the property, which puts the property in potentially imminent risk of failure to the property as well. Following the slope failure, Optera were invited to develop a scheme working with the loss adjusters in order to remediate the slope failure. We've taken a phased approach here. So the very first stage was to deal with the immediate slope stabilisation issues. Because of the difficulties of access with this site, everything has had to be done by hand. Material that's been dug out in order to create these terraces has had to go down the slope. There is a beneficial effect to that because we need the mass of material at the base of the slope in order to create that stability at the toe of the slip. In order to facilitate safe access, we've also had a specialist scaffold designed that gets personnel safely from the top of the slip to the base of the slip. Following the initial slope stabilisation, Optera worked with the client to develop a final design, allowing us to reinstate the policyholder's lost garden. The agreed design was based on a screw-piled ground beam that was laterally restrained using a series of divvidag ground anchors. On top of the ground beam, we constructed a restrained king post wall using galvanised steel posts with oak sleepers in between. The lost ground behind the wall was made up using lightweight Cordec fill core, which is a structural grade polystyrene fill material. This allows large volumes to be filled quickly and safely without adding weight to the head of the landslip area. Once the fill core was placed, we added free draining gravel with topsoil and turf. The design provides a robust solution to a common landslip situation. The new wall allows for ongoing maintenance without compromising the structural elements.
Optera were engaged approximately 5 weeks ago by our insurance clients following a retaining wall failure at the property behind me. The section of retaining wall that's failed has fallen into the road, and the local authority have initiated a road closure which we've subsequently adopted. The retaining wall itself is a dry stone construction and has collapsed into the road from a build-up of hydrostatic pressure behind it. That's been flattened now to give us a working platform. Unfortunately, the rear right-hand corner of the property is particularly vulnerable, being very close to the centre of the failure. So we've underpinned the rear right-hand corner to stabilise it and take it down below the angle of repose of the failed bank here. We're now moving to a second stage of repair where we'll be stabilising the bank using rock anchors and a geotextile fabric reinforced called MacMat. The anchors themselves are 32mm hollow bar with a sacrificial drill bit, which is drilled into the slope using the Marini mast attached to the excavator. These bars are air flushed, clearing the spoil from the slope and allowing us to grout with a cementitious grout, connecting the substrate to the MacMat and securing the slope on a temporary basis. Once this has been completed, the soil is cleared from the site down to ground level, at which point we've constructed a ground beam just below road level, which is a reinforced concrete ground beam with L bars, allowing us to reconstruct a hollow block retaining wall behind the new stone face wall. Stonework is connected to the reinforced concrete wall behind, creating a sympathetic stone faced wall which the locals complimented us on upon completion. Accents of the engineering involved in the project can be seen with the Patris plates connecting the hollow bar anchors through into the stone face, which manage the moment generated around the toe of the wall. The locals have been very complimentary about the finish of the wall, complementing the general surroundings. This particular property in Laddingford in Kent had suffered in the winters of 2016, where flooding had occurred and the sudden fall in water table had reduced the levels of the property with hydraulic consolidation of the peat soils underneath the foundations, resulting in distortions of approximately 300mm from front to back of the property. Optera undertook investigations and devised a scheme to dewater the property in order that we could fulfil a piling scheme which would subsequently be jacked to level the property. In this particular case, we elected to use 150mm case-driven steel piles which were driven using a D500 piling rig down to competent strata at approximately 8 metres. Computer-controlled jacking operation was undertaken across a single afternoon, lifting the building back to its original geometry and correcting distortions. Brickwork was rebuilt below ground level and subsequently we undertook superstructure repairs to return the property to its pre-loss condition.
We got a call in from our client last week with a reported collapsed mine shaft. We were in attendance on Saturday with one of their representatives just to obviously assess the situation.
It was just a sense that the cavalry had arrived. They were absolutely lovely, very sympathetic, very caring about our situation.
We were actually on the ground on Monday setting the site up and determining exactly how we're going to cap the mine shaft off. It's a very big hole. And we can't get very close to it, hence the reason why we've had to have the scaffold put up over the hole itself. I mean, the actual hole itself measures an approximate diameter of around 10 metres. We ascertained Saturday, because it was very precarious, obviously getting anywhere near it to measure it, but we took a rough estimate, it was 8 to 10 metres deep. I suppose you could say if you put a double-decker bus in there, you'd probably see just the back end of it sticking out, not a lot more. I mean, to put it in a blunt terminology, you know, there's a risk of the collapse of the actual property. Because we've got an actual mine shaft there, there's a lot of debris fell in, which has formed a natural plug. So what we're actually doing now is pumping in a foam concrete, which is a lightweight concrete compared to usual concrete. That'll then actually spread over the top of the debris, plug any small voids or holes, and then basically fill it up. As the actual formation of the hole is, probably the only way to describe it is like a wine glass. So you've got that effect. So once you've got concrete that's filled that kind of hole, there's no way it can slip down. So it acts like a natural plug, a bit like a cork in a bottle or a lid on a coffee jar that you'd have at home. To take on a project this size and actually bring it in within a kind of 6-week period and actually get them back into the property, you know, in a safe, habitable condition, you know, it's quite a massive task really. We tend to thrive on projects that are non-standards.
Optera have been absolutely wonderful. We can't speak too highly of how they have handled everything from beginning to end. We just felt very relieved and very happy to leave it all in their capable hands.
Hello, I hope you enjoyed those videos. Spencer, those were great. Thank you for that.
Shameless promotion.
I think we're going to get a bit of audience participation now with some poll questions. So it gives everybody a chance to take part a little bit. So if we can launch the poll. I look forward to voting this week. I couldn't vote on my own poll last week. Good news for you there, Spencer.
Still some skeptics amongst us. I've got to be at least 70% now.
There was quite a flurry of activity on the chat box as the works way. So actually, because we're pushed for time, I'll ask you some questions while these are on the screen. One of the questions was that the Harrow example where the root barrier is being installed. What trees was that in respect of?
So the trees on the left-hand side of the house were described on the Arbor report as TG1. So they were undefined as regards any specific trees. It was the vegetation down the left-hand side of the property in general.
Right, okay. I think you've got one more question. And there was Andy Tipping was asking quite a few questions about the suitability of root barriers for implementation where there's a street tree involved, whether root barriers are able to be built around services in the street. Is that a possibility?
So we do lots and lots of root barrier installations where we're at the front of the property, and typically services are coming in through the front of the property. So the barrier itself is cut and taped and seamed around, but so you can bring a barrier across a number of services and tape and seal around those services that are then brought through and across the barrier itself. So yes, that's not an issue. The tree root barrier, I've been obviously keeping an eye on the questions that are coming through. One of the issues that I did see was how close can the barrier go to the side of a property. Yeah. We can, I mean, typically we install those as far away from a property as we can do for obvious reasons, and they're typically installed in 5 meter lengths, but we can bring down the barrier to about 1 meter from the side of the building, and the excavations are then done in much shorter lengths of sort of 1.5 meter lengths, as you might typically do a traditional underpin.
Right. Okay. We're sort of encroaching. Let me just pick out one more question. And again, like last week, with the questions that aren't answered at this point, we will go back and answer them and put the answers on the Subs Forum website. So there was quite an interesting question, because there were lots of quite catastrophic examples. You've got there, a sinkhole. You've got catastrophic, failure of a retaining wall.
Yeah.
Where a property is at risk of imminent collapse, how quickly can you get on site and stabilise that property?
So with regards to all of those jobs, we would typically be looking to mobilise the site within a week at the very latest. Some of those jobs, I mean, the sinkhole, for example, the mine shaft collapse, we were notified of that on the Friday with a Saturday morning. You kind of assess the situation based upon the information you're given. Okay. So I mean, there's enough people around, and we can move jobs around and move staff around so that we can access those sites very quickly.
Right. Okay. Well, sorry to cut you short there, Spencer. Thank you very much for your videos, and let me hand over now to Alex Finch of GeoBear. Alex, do you want to do an introduction to your videos?
Yeah, thanks, Sarah. Morning, everyone. Just a quick thanks to the Subsidence Forum for putting this event on. I know it's not quite the same as the normal one. We're all out and about on site, but hopefully people enjoy it nevertheless. So we were asked to show a couple of videos regarding our clay shrinkage solutions. I think people might be more aware of the granular solutions, but we've been working in shrinkable clay for the last 4 or 5 years, a lot in the UK and a lot longer in Southern Europe. So what we've done, it's quite difficult because you can't see much because we work above ground, obviously, with our solution. So what we've got is a short animation which kind of shows how it works. And then we lead into a video we filmed at a property on a project 2 or 3 weeks ago in North London, just taking you through kind of the process and how it works. So hopefully that'll be of use to you. I can only apologise for the presenting skills, as you'll see, but we did our best. Anyway, so here goes. We're here in North London filming a project for the Subsidence Forum. This is a clay shrinkage project. We received the instructions from a loss adjuster. We've carried out our visit, we've done our site survey, and we can have a look at the project in a moment. It's a very typical clay shrinkage project. There's tree roots involved, a desiccated clay. We've designed the solution, and today we're going to have a look at exactly how our process works, so we can see our technicians drilling, we can see the injection process, and have a look at both the enabling work and how we protect services. So this particular project is a very typical cause of clay shrinkage subsidence, particularly in the North London area. Trees are normally involved where roots below foundations are extracting moisture during prolonged dry periods. That obviously weakens the clay soil, the foundations move downwards, hence we have a subsidence problem. The loss adjuster would normally carry out site investigations so they can determine the soil details and the foundation depths. They pass that information on to us. That enables us to complete a design. So the loss adjusters may well have considered other options, for example, traditional mass concrete underpinning or possibly piling. And there's benefits of those. The disadvantages are they generally take longer, they're far more disruptive for a customer, and there's obviously price differences. With the GeoBear solution, our methods are usually completed in 1 to 2 days on site. Customers never need to move out of the home, and the disruption is generally far less. So we're going to talk to James, who's managing this project, and he'll tell us about the process and how he's designed it. So after our instruction, did you need to visit the site?
So after the initial instruction, we attend site within 3 to 4 days on average, and it's a really important part of the process because we both need to see what the problem is with the subsidence, what areas of the property are actually moving, but also how we would physically do the job and what obstructions there might be for us doing the job.
What information did you need to complete your design?
So the information we get is a site investigation is the most common thing. So that is a trial pit to see the depth of the foundations, but also a borehole to see the depth of any roots, any desiccation zones, and also to work out if there's any services as well.
How do you decide upon the depth of the treatment?
So the site investigation, the material is then sent off to a laboratory and they analyse things like root depths. And our treatment has to go 1/2 metre below the lowest roots in the borehole. So at the back of the property, the roots were just below the foundations. So we made our treatment 1 metre below the bottom of the foundations, which made sure we were at least 1/2 metre below the lowest roots. But at the front, the roots were actually deeper. So we had to make sure we really covered that root depth and went 1/2 metre below that. So we had to go 2 metres below the bottom of the foundations at the front.
Is there any enabling work involved in this project?
There was some enabling works required, I mean far less than would be required with a sort of traditional approach, but the client has decking across the back of their property, they have concrete up the sides with various services in, so we had to take up the decking, we had to do some internal work to monitor the floor suspension because this is a suspended floor, but relatively minor and something that a contractor could do in a day or something like that, part of a day, so quite minor, but yes, there was enabling works.
What about services and drainage?
So we get first thing for drains, we get a drain survey. So the loss adjuster would instruct a drain survey only if in the area of the subsidence, but that's quite common that you get a drain survey, A, to work out exactly where the drains are to make sure we're not going to go anywhere near them, but secondly to actually work out the condition of the drains, because if there's any big defects they would need to be repaired before we did the works. And then services, I would scan for services, so we do a check when I do the initial site visit, and I try and work out if there's any gas, electricity, water. And if they're in the area, then we'd have to expose, and we'd have to, from a health and safety point of view, to make sure we didn't hit these services when we're doing the drilling and injecting works.
How long does a typical GeoBear solution take?
So a standard project is 1 to 2 days. This is actually quite a big project. It's large parts of the house, so this is more like 3 or 4 days. But we're all done within a week, and the client the policyholder doesn't have to actually move out of the property. So it's very little disruption to them.
So a common problem we encounter for subsidence is leaking drains near foundations.
That's usually in a granular soil. So if you can imagine that the leak from the drains erodes, washes away the fines from those soils below the foundations, and then the foundations move downwards. Now that's not the problem we have on this particular project. This is about clay shrinkage. And this property in North London, the damage has come around from clay shrinkage, but the primary concern has been nearby trees. In this particular case, we have quite a big oak tree here, maybe 12 to 15 metres in height, and around 15 metres from the rear of the property. Now you might think, well, that's quite a long way, surely the roots can't get beneath those foundations. Yeah, they certainly can, and a rough rule of thumb is if a tree could fall and hit the property, the roots can certainly get underneath those foundations in a prolonged dry period, and that's been the case here. This one is started during that long summer drought of 2018, and the problem's got worse since in the subsequent summers. So the design has been approved, and that's passed over to the senior technician, and the team of technicians are now on site. They've completed the enabling work and the drain monitoring's been set up. So the next phase of the process is to start the drilling. So with either 12 or 16mm diameter bits, we're drilling down through the foundations to get to the required depth as per the design. From there we can insert the injection tubes and start the injection process. And that will be injecting the specialist geopolymer to the specific depths required by the design, which will then strengthen the soil, and that completes the process.
What sits behind me is our standard, pretty much standard truck now for our, and on that carries all our equipment. So that includes all our health and safety, all our drilling equipment, and we also carry the resin in there for each job. Okay, so this job in particular was down for ground improvement on a foundation that's about 1.3 deep. So the choice for us then was to either drill through the foundation multiple times, or drill through it once, put a longer tube in, and then extract it at metre increments to achieve the same thing. So it assists with the halves, and so we're not drilling through the foundation so many times. This resin, it stays liquid for longer to permeate into the high plasticity clay. So we can actually get more material in the ground as opposed to a material that would expand a lot quicker.
Once the injection process has been finished, we can simply cut off the tube slightly beneath the surface, and we can cover up. In this case there's concrete, so we will just cover that up with a mortar finish. This project is now drawing to a conclusion, and the technicians are clearing up on site, and the final part of the process will be to complete the penetrometer testing, so we can determine the strength of the ground after our solution has been completed. And from there on we will send a final report into the loss adjusters, and we can wrap this project up.
Hi. Great, those two videos were great, Alex. Thank you for that. So I think we're going to have some poll questions from you as well, so give a bit of time for some interaction. I've been monitoring the Q&A in the chat box here. It's like there's a flurry of activity with loads of interesting questions. Has anything popped up that you specifically want to answer, Alex, in the chat box?
Yeah, it looked pretty busy, which is great. I think I saw one question come up a few times. It was around, do we just treat when it's desiccated, so like summer, autumn? No, we don't. We can treat all year round. The designs might be slightly different if we're treating a more rehydrated clay to a more desiccated clay. But generally, it's a similar amount of material we design to be injected into that soil. The spacings might be slightly different, and it might be a slightly different geopolymer. So we might use a slightly different one if it's a wetter clay as opposed to a drier clay. But we can treat all year round. So when it's desiccated, the resins we use expand far slower in clay, and they just find all the voids and fissures. If it's a bit more rehydrated, the resin's injected, but it starts to force the moisture out of the clay, and then it starts to fracture and form its own voids and fissures. So yeah, pretty much all year round.
Another one that I saw quite a few questions about was how do you avoid this polymer going into the drains and blocking up the drains?
Yeah, good question. And we have been caught out in years gone by where we have actually got it into the drains. We've had to come back and either high pressure jet wash it through, or on one occasion we had to replace some drains. So we've kind of changed the process a few years back. So we always have a drain survey if there's drains within the zone of our treatment. If there's severely displaced joints or anything we're worried about, we would recommend that the drains are lined before we treat, which I guess they'd want to do anyway because they've got a drain problem. And then we have drain monitoring on every job. So we put the CCTV survey into the drain to keep an eye on it. Should any material seep in, we have a high pressure jet washer on site so we can just flush that through and either move the injection points or carry on if that's okay.
And one question I wanted to pick up on, because I feel like environmental considerations are more and more at the forefront of everything we do. I mean, they should be. You know, we're dealing with trees, we're dealing with the environment. So, yeah, what are the environmental consequences of the treatment that you do?
Well, initially, we've done comparisons to traditional underpinning. So in terms of the environment and CO2 emissions, we use 90% less CO2 emissions than traditional underpinning scheme for our on-site works. In terms of accreditation and testing, we've had to have independent tests for leachate testing, which is BS 12457 in accordance with that British standard, which basically confirms that the different resins we use are benign and do not have any effect on water courses or water table or anything.
Excellent. What other ones did I find? And there was one question that popped up about differential movement. So obviously, if you're doing some work at a part of the property, is there a risk of differential movement between that and another part?
Yeah, good question. Yeah, I mean, in the olden days when I used to actually do these projects, we used to do trad underpinning, and to help with differential movement, we'd use we'd step the foundations up as we moved away. That kind of worked. It's completely different with the geopoly technique because we're not mass filling. So the resins we're injecting into the soils doesn't mass fill it. It just forms a new sort of composite of soil with resin. So there's still movement. So we don't create a hard spot like you might do with underpinning. It still allows some movement. So for example, if you did some level monitoring, you'd still see a bit of movement in that soil, just not enough to be able to damage a property.
There was one question that came through because you stood there in the garden with the oak tree behind you, which was lovely to see. So I presume that a lot of the work that you do involves the trees remaining in situ, and you're doing work to stabilise the property in the continued presence of the trees. Is that right?
Exactly right, which is another good environmental one. So basically, and I think another question came up about, do we treat every clay? At the moment, we treat clays up to a 40% PI. So, and the reason we go up to 40 is because it's tried and tested through Southern Europe and the UK, so we know that's successful and it works in all conditions. So above 40 PI, we provide solutions if required, but there's more of a risk element to those very high PI clays, which we're under research and development at the moment. So anything up to 40 PI is good, and the trees can stay. So what we're doing is not only solving the particular subsidence problem at the time that's been created by the clay shrinkage, so that bit's the easy bit. Then what we're doing is, in effect, bringing the PI down. So we're drastically reducing the shrink swell potential of a clay by injecting the resins in there and changing the composite of that soil.
And they can live in harmony with one another. It doesn't affect the roots of the tree.
No, so the rootlets, we're actually starting a study with a tree professor, whatever they're called. But there's this chap's helping us doing a study on any type of effect on the rootlets of trees. We haven't found any damage to them at all so far over the years, but we're actually doing a scientific study just to see, does it suffocate fine rootlets or does it have any effect on them? We don't know if it does at the moment, but we'll see if the study brings anything out on that. But so far, we've come across nothing, no effects on tree roots.
What about the longevity of this as a product? So is this a permanent solution?
Yep. Yeah. So it's the actual material guarantee by the scientists who've invented it and provide it for us is 100-year material life they've put on it. We can't obviously vouch for that because we're only about 43 years old. So what we can say so far, it's good for 43 years and still going. So,
is Spencer still there? I wonder if I can bring Spencer back in, because there was a question that cropped up in the first Q&A, which would probably, hi Spencer, probably to ask you both. So somebody popped in the chat box, it's really interesting to see these solutions. They look time effective, they look cost effective, they look environmentally effective. So one question was, why aren't insurers using these? So my question to you guys is, are insurers using these? And are you seeing these being used more and more often, as opposed to just simply asking for trees to be cut down?
Do you want to go first, Alex?
Oh, sorry. Yeah, sorry, I thought you were in there, Spencer. Yeah, in terms of insurer use, we're finding quite a lot of insurers are using it. Some have gone for it big time, and in the last 2 to 3 years have actually recommended our solutions and kind of working in partnering with loss adjusters. Some are dabbling a bit more and taking their time, but we're finding more and more are using it as the months go by. And also, I mean, it's not just insurance, and I think some of your attendees are maybe not in the insurance world. A lot of social housing and councils are using it as well. It's a big one for them because they don't want to decant people from houses. So if you've got a solution that's 1 or 2 days and you don't have to move out, it's a big winner in social housing as well. So we're finding the uptakes more and more as the months go by.
From our perspective, root barriers have been used now probably for about the last 7-8 years. Started off with a couple of insurers. We seem to be working for most of the mainstream marketplace now. And some high net worth insurers, but just down to the lack of disruption to policyholders and it providing a robust solution to the issue. And equally, we're finding local authorities now using these and instructing us to negate their own liabilities with respect to street trees.
Yeah, I'm seeing that quite a bit. If a request is made of a local authority to remove a tree, they may come back and say no, but we will pay and we'll get a root barrier installed as an alternative. Yeah. So then look into the future. I know we're in a bit of a weird time at the moment, but what do you two guys see as your future, as the future of subs?
Well, for me, I mean, I worked in it for 20 odd years, and like Spencer, we've kind of been through that period of the early mid 90s, where if it moves, underpin everything you see, and then we kind of moved into mitigation and then lengthy monitoring periods and battles over trees and so on. It's quite refreshing that there's some options out there now. You don't have to have, whether it's an insurance claim, 1.5 years odd of monitoring and hoping that it will work. There is a genuine solution to really, really expedite a claims process, which is obviously great for customers, but it's also good for insurers. And overall, you can bring the overall spend down. And this is our solutions. One, of course, there's other ones, but I think the future is bringing insurance claims in particular, bringing them down to a lot quicker than they have been in recent years.
What about you, Spencer?
From our perspective, echo a lot of what Alex says. This is root barriers I kind of see as a very quick reaction to a problem. We've tried to promote root barriers as a sort of almost instant response. I think, like Alex, I've spent 20 years investigating subsidence claims. You generally know when you go to a property, when there's 5 or 6 oak trees in the garden that were planted when God was a boy, you're probably not getting them removed. And the formulaic approach of trying to assimilate enough information to try and challenge a TPO and ultimately that being refused, establishing recovery and then going to some underpinning solution is ultimately very, very costly. It generally disenfranchises the policyholder during that process. Root barrier could be installed very, very quickly. And we've seen all the damage that occurred in 2018 and those claims where they've pursued third parties and TPOs. We had a dry summer in 2019 and 2020, and those that didn't get a very rapid response have deteriorated substantially, and the damage they saw in 2018 has deteriorated quite substantially to the point now where certain properties I've looked at in 2018 now require taking down and rebuilding. Had they gone for root barriers at the early stage, they could have negated a lot of that.
Well, one question that I saw pop up was about the Party Wall Act. Do either of you guys have to deal with Party Wall Act notices with the solutions that you implement?
No, we don't, because we're not excavating. And in terms of the Party Wall Act itself, we don't come in under kind of its jurisdiction, so we don't know. I mean, we liaise with neighbours, obviously, as a neighbourly gesture to make sure they know what's going on. But formally, we don't come under the Act.
What about you, Spencer?
We do. We have TPO. We have party wall surveying capabilities in house. We also have TPO application, so we offer sort of complete turnkey service, whether that be for root barriers or any other solution that we might do.
That's great. Well, Patrick has popped up on the video, which I mean, if I
like the Grim Reaper.
As I said,
I wanted to ask a question, Sarah.
I'm not interested in any questions you've got to ask.
Okay, well, there was one that cropped up a few times about guarantees. What sort of guarantees are offered on these products?
I saw that one. Yeah, that's fair. So our guarantee, it's a 10-year insurance back guarantee. So what we tried, and here's a fun fact for you: we initially tried to join ASUC, but because we're not viewed as underpinning, we couldn't. So what we've done is mimic the cover that you can get on an ASUC guarantee. So yeah, we've got a 10-year insurance back guarantee for our solutions.
Root barriers have a 10-year warranty. We can offer 10 or 12-year warranties on underpinning or any of the other repairs. Insurance back warranties, they're available. Depends on insurers' appetite for independently insuring something they already insure. You'll have some insurers that take the view that continued insurance of the property is that they didn't have an insurance policy before the works were started. That duplication of insurance on those repairs is something they don't want to fund, but it's their horses for courses.
Right, okay, well, we've just crept past 10 o'clock, so I think we're going to have to bring it to a close, which is a shame. It's obviously attracting a lot of interest. The chat box is overflowing. I think we'll try and respond separately to some of the questions that have been raised that we haven't got round to, so we'll probably do that outside of the webinar. But yeah, sorry, we've run out of time. I'd like to say a massive thank you to Spencer and Alex. I thought both demonstrations were brilliant. I know how long and how much work goes into producing these videos, so thank you very much. And you probably have to imagine it, but I'm sure everyone at home is clapping and cheering. So well done. Thank you very much for your time.
Thank you.
Just a quick couple of points. Again, the whole thing has been recorded, so you'll be able to view your performance on the Subsidence Forum website in a week or so's time. There's also a very short survey that will pop up when you log off the webinar. Just a couple of questions, but if you can take the time just to complete that, it helps us plan these events going forward. Finally, just a plug for next week, our last demonstration of this year, site investigations and masonry reinforcement, starting at 9. If you haven't registered yet, please do so and get your friends and colleagues to do likewise. So that's it for today. Hope to see you all again next week. And until then, stay safe. Thank you very much.
Thank you. Bye.